Welcome, gentlemen, to our next exciting film. I know that you've been waiting for this one for a long time, so here we go. Now, today's topic is maybe, yes, pH. pH we've talked about being acidic, basic, that kind of thing, but what exactly is pH? pH is the measure of the molar concentration, denoted by a bracket symbol, of the hydrogen ion concentration in a solution. What the heck does that mean? Well, okay, so molar concentration, right? We've talked about solutions, right? They have a capital M, and in this case, it's hydrogen ion. So these are acidic compounds. And when we write it, we use a bracket. So for example, if I'm talking about a solution that is 0.125 molar hydrogen, I would write it like this. In brackets. You with me? Not too hard. Okay, next. The term pH actually means the power of hydrogen, so that's where it came from. So in this case, we're going to be actually using our calculators, and we're going to figure out what the power of hydrogen is. That's where it came from. It's an old term. And the formula for calculating the pH of any solution is the negative log of the hydrogen ion concentration. The negative log of the hydrogen ion concentration. Now, I just happen to have a picture of my very famous TI-84 calculator. I think it's an 84 plus. It is, left by some student many years ago, because I certainly wouldn't color the keys on my keyboard. But anyway, I digress. So let me show you on your calculator where to find those different things. First of all, this is the negation key, which is the one down here below the 3, negation, not that key. It won't work. The log key is right here next to the 7, and then the hydrogen ion concentration is whatever it is that the problem is asking you for. So let me show you. What is the pH of a hydrochloric acid solution that has a hydrogen ion concentration of 4.23 times 10 to the minus 9th molar? Okay, so what is that? Well, let's get our calculator out and let me show you. All right, so here's the problem. Here's my little calculator over here. And so first of all, got to identify my variables. 4.23 times 10 to the minus 9 molar. I think that's the only variable I've got here. Good. Now I need my equation. pH is equal to the negative log of the hydrogen ion concentration. And I'm moving over to the side here, so I'm going to put in pH is equal to the negative log of 4.23 E minus 9. And the pH is equal to. So let's do this on our calculators now. So negative log. So do this with me. So I hit negation key first, followed by the log key. And then I hit 4.23. Now we've got to go back to our 10 to the key. Remember that, our EE right here. So you hit the second key and then the comma, which is the EE key, which will give us the exponent, and it's negative 9, so we have to go back again to our negation key, hit 9, then hit enter, and you should get 8.37 as the pH of this particular solution, which puts it above 7, which means that this solution is actually basic. It's got a reasonably low concentration of hydrogen ion, and so therefore it's actually a little bit more on the basic side. All right, having done that, here's yours on your own. What is the pH of a nitric acid solution that has a molar concentration of 3.38 times 10 to the minus 2? Hit pause because I'm going to put the answer up while you do that calculation. And yes, the pH is 1.47, exactly what you got. Very good. Pretty simple calculation. All right, let's move on. Now, let's say we're given the pH and we want to know what the hydrogen ion concentration is. Oh my God, how do I do that, Mr. Nolan? Well, here's how it goes. If we're given the pH, to get the hydrogen ion concentration, all we need to do is set our calculators, make the calculation. Hydrogen ion concentration is 10 to the minus pH. So it's an exponent, 10 to the exponent negative of whatever the pH is. And I know you already know that I have an example problem for that one. So let me dig that one up. If a solution has a pH of 3.78, what is the concentration of hydrogen ion? Good question, Mr. Nolan. Well, what do we know? We know that we have a pH being, oh yes, identifying variables, 3.78. I want to know what my hydrogen ion concentration is. Boom. And my equation is hydrogen ion concentration is equal to 10 to the negative pH. So let me bring my trusty calculator in. Well, my calculator is crusty and trusty. Trust me on that one. All right, so, sorry, I digress. A couple ways to do this. First of all, we can say, so we've got our hydrogen ion concentration is equal to 10 to the negative pH. So what we can do is we can hit 10, and then hit our caret key, right here, the caret key, so that'll automatically exponent that thing. And we've got 3.78 as our pH. So we hit, and again, and remember now it's the negative sign here, right? So we hit the negation sign, 3.78, and what we get for our answer is 1.66 times 10 to the minus fourth molar hydrogen ion concentration. I didn't have room to put the H plus over here. I suppose I could have, but that's the way that goes. All right. Well, here's another way that you can do that if you're so inclined and being so technique savvy. Let me show you a different way using your calculator that you can do this. So let me erase what we've got here. If you look over here on your calculator, right here, above the log, you got a little 10 to the x. That little key right there, how you access that is you hit second, then you hit your log key, and what that gives you is this. That puts that right up on the screen, sorry. And then you enter your negative 3.78, and you will get that same answer there. So there's two ways to do it. You can do your 10 caret key times 10 to the, and then you hit your negative 3.78, or hit second key log, which will give you the 10 to the caret, and then hit your negative 3.78. Either way will give you a correct answer. Good, lads, good. All right, there you go, of course. What is the hydrogen ion concentration of a solution with a pH of 1.16? Again, hit pause because the answer is right here. That was easy, wasn't it? So far so good. There's really nothing really overly challenging about that. You got a couple formulas and that's how you use them. All right. So let me throw another quick concept at you. Two more quick concepts, then we'll be finished. Hello, boys. How are you? Wow, how did she get here? Sorry about that, lads. Got to keep those interlopers away from my calculations and my movies. Anyway, so here's a cool little thing. Pure water. Let's not get too bunched up on this, all right? But pure water ionizes slightly, and the hydrogen ion concentration is 10 to the negative 7th. And what's this? What is this madness? The concentration of hydroxide? Oh no! Yes, the hydroxide ion concentration, which is a measure of base, right, if you remember, it is also 10 to the minus 7th. So we run those through our trusty little formula. pH here is 7, pH here is 7. Pure water, unadulterated, neutral pH is 7, all right? The hydrogen and the hydroxide balance, which of course makes sense, which is why I've been writing water like this, because those two things are equal to each other in that calculation or in water, pure water. Water is rarely pure, as you know. Comes from the tap, it's got all kinds of stuff in it, which makes it slightly acidic. Slightly acidic when it falls from the sky, picking up carbon dioxide, etc. in the atmosphere, as you know, makes carbonic acid, blah, blah, blah. So there you go. However, now that I've brought this little guy out, this hydroxide ion concentration, I want to show you another quick calculation, which of course you'll be able to do because you guys are pretty darn smart. We've got something known as the POH. POH is the power of hydroxide, as you could probably imagine. And the calculation is the same, except we're using a different quantity. It's hydroxide instead of, or not quantity, but ion. We're using hydroxide instead. So now this is a measure of the base, or how basic a solution is. So let's have an example, of course. What is the pOH of a sodium hydroxide solution that has an hydroxide ion concentration of 5.33 times 10 to the minus 4th molar? Well, we already know how to do that, so let's quick set it up. All right, our let's go with that. Our hydroxide ion concentration is 5.33 times 10 to the minus 4th molar. It's a minus right there. And we want to know what is the pOH. So pOH is equal to the negative log of the hydroxide ion concentration. So it's a negative log of 5.33 times 10 to the minus 4th. And the pOH is 3.27. Interesting. Let me show you something here, all right? Let's see if you can figure this one out. So, when we're dealing with pH and pOH, when you're trying to find pH, pH is equal to 14 minus the pOH. pOH is equal to 14 minus the pH. Interesting relationship, huh? Interesting. So let's look at our last calculation. 3.27, we have a pOH of 3.27. So what would the pH be of that solution? Trusty little calculator out. The pH is equal to 10.73. Basic, right? So there you have it. A quick little film, well, about 13 minutes and 30 seconds worth of film on some pH calculations, pOH calculations, etc. I will see you tomorrow in class, lads.